Okay. Hi, my name is Schuyler, and today I'm going to be talking about how to be a Chisel and/or FIRRTL and/or broader Chisel FIRRTL project developer. So first off, why does this matter? Why should you care about this? Why should you think about trying to contribute? And really, there's sort of a lot of sort of multidimensional reasons here. Some of which are just sort of immediate. Hey, maybe you found a bug or you think you found a bug and you want it fixed and you want it fixed now. The best way to do that is to fix it yourself. The second best way to do that is to give a minimum working example and file an issue, and then that usually gives somebody enough information to act on it pretty quickly. And sort of the second immediate reason here is that you have a feature request and you need it. So something like this could have been if you really needed asynchronous reset. Before when we didn't have asynchronous reset, this could have been something that you pushed on. Or if you want FPGA preset reset, that different style of reset, that's something that you can push on, and it's something that you really want. So granted, these are sort of for the majority of Chisel users, these two reasons are probably not enough to say, hey, I want to start being a developer. But there's sort of all of these other meta reasons that generally just may make you a better programmer, a better user. So first thing is, if you like Chisel, this is like a great way to connect with other people and to try and help with the project. If you are a Chisel developer, and anything that you contribute, if it's documentation, if it's it can be as simple as fixing typos and readmes. I mean, any of this stuff is important. It helps make the project look more professional. It helps the whole thing succeed. If you want to better understand Chisel internals, this is a great way to start doing a dive on that. Why are things constructed the way they are? Why do the APIs look like they do? Why is there .u and .w? What happens when I type module? That kind of stuff. And through all of that, the things that you pick up will probably wind up making you a better Chisel user, potentially more valuable to your employer, or allow you to write better projects, all that kind of thing. And potentially also useful is that if you work at a company using Chisel, or you want to try and get this as something that is used by your company or used by your peers, doing these kinds of deep dives will get you more acquainted with the code base and better able to answer questions, better able to help people either internal to your company or external, on Gitter, on GitHub, on Twitter, on Stack Overflow, all of that. So basically, it should theoretically make you a better Chisel user. So, and I guess I probably should have put a reference here, but there is, I believe there is a study done that companies that contribute to open source projects are actually extracting more value than companies that use open source projects but do not contribute. So you can look that up probably in Google, and it'll come up with the answers for you. Oh, and then finally, so you want to interact with other Chisel and FIRRTL people. Like, you met people here and you think they're fun, or you want to talk with them more, or you get something out of your interactions with them, and this is one way to stay connected to that community. All right, so general information. So everything in sort of the Chisel FIRRTL ecosystem at this point is Apache 2. Anything that you contribute, you need to make sure that basically assert that what you are providing is licensed under Apache 2 and you have the rights to contribute it. So what does that actually look like? So just to give you some idea of what this is, and if there's any questions and any of this stuff comes up, just let me know. Yeah, so the internet is just a tiny bit slow. But so if you just go to the FIRRTL project and you go to a random pull request, and I could probably make this a little bigger. So there's a number of checks that run down here. So this PR that I have, which is not working, I clicked on the wrong thing. But there is a rule here for, where's this? License CLA. So there's this thing down here. So there's basically a check from a project, which I can't remember exactly the name, CLA Assistant. But what this is doing is when you file a pull request, it's checking against a list of users who have signed the contributor license agreement. So the text on this is pretty small, but basically this is just saying that you have the rights to contribute this, and what you're contributing is going to be under the Apache 2 license. There's a little bit of a current caveat in that, which we need to update, but FIRRTL was originally contributed under BSD 3+. You sign into GitHub on this, and after that, then it will come up and say, do you want to, what is your name, what is your email, you read the CLA, and then whether you're signing on behalf of yourself or on behalf of your employer. And then you basically just fill it out and you're good to go. So that's sort of just the logistical stuff or the infrastructural stuff that we have in place to sort of get people to manage who owns the contributions and to get all that stuff licensed correctly. All right, so projects and versioning. So this is sort of a rough list of sort of the core Chisel FIRRTL projects, if you will. So you know Chisel, you know FIRRTL, you know that there's different testers projects. There's Chisel3.io testers, which is sort of the old tester, and then Chisel test, which for a while was called testers2, which is Chisel3.tester in terms of your import name. There's FIRRTL, which is a FIRRTL interpreter. There's also FIRRTL interpreter, which is the old FIRRTL interpreter, which is replaced by FIRRTL, hence the strikeout on this. And there is Diagrammer2, which I don't know if anyone's seen specifically, but this is really cool. It'll let you generate like nice SVG graphs from FIRRTL circuits. So, but the key thing here is that in terms of the versioning that we follow sort of a non-standard semantic versioning scheme of basically major or the first number doesn't really matter that much. The second number is sort of the major number, and the last number is the minor number. So in this case, what that means is that we guarantee binary compatibility across minor releases, and we have infrastructure set up to help maintain that we don't break that. So what does that mean? So that means if you have a project and you're using Chisel version 3.2.0, and then you go and bump to 3.2.1, it is supposed to just work. If it doesn't work, it's our fault. But we have a lot of stuff that's checking to make sure that things are binary compatible. So we're basically trying to provide that guarantee for everyone. Additionally, that means that projects which are all under the same, so like Chisel 3.2 dot star and FIRRTL 1.2 dot star are all going to work together. But generally, you don't have to specify these versions, explicitly. Just you specify the version for one project, and that pulls in all the dependencies that it needs. Okay, so what does that all mean? So all that means is that if you're contributing something to Chisel or FIRRTL, which is actually not in the slides, but I will talk about this at the end, you sort of have to think about what you're doing. Is it something that is a bug fix that makes sense to go in a minor release, or is it something that should be going to a major release? And you can always default to major release. That's always fine. That's not going to hurt anybody. If it goes into a minor release, this stuff like Adam talked about is automatically backported, and we check binary compatibility on it. If it fails binary compatibility, it's not merged. So there's no problem in saying something you think it's a bug fix, but it actually changes something. All right. So this was all just general information about everything going on, and then sort of jumping in here. There's really a lot of ways that you can contribute, and there's sort of a lot of different, let's say, time scopes that may involve. So the first thing, which I was talking to people a little bit before the session, the first thing which really matters is documentation, right? There's been a big push on the Chisel and FIRRTL projects to get tons and tons of documentation on ScholaDoc, on the website, to make it type safe, all of that. So there's a lot of ways that you can get involved with that on helping out with either updating the website, adding new examples, documenting more features on the website, or updating or improving ScholaDoc, which is sort of our API documentation. And I'll show you what this is as we sort of step through all of the different ways you can contribute later. The stuff on the right is just sort of an estimate of what I would say the upper bound is on, how much time commitment you can be, let's say not time commitment, how long you can expect to be having to think about this. It's not necessarily time commitment, it's just that, how long might you be going back and forth with the developers on pull request reviews, modifications, that kind of stuff. Okay, so documentation is great. It's an easy way to get involved. I'll show this too. Anything that you contribute, your GitHub handle will show up on the website just automatically, just as our small token of thanks for what you're doing. So any of this, if you contribute to the website or Scala doc, that all shows up. All right, now then, in terms of mainline sort of code modifications, there are always tests that need to be written. This is sort of an easy way to get involved. There's things in the Chisel standard library which you can think about, write more tests for, make sure that this stuff's bulletproof, check that requirements that we have on Chisel 3 standard library artifacts are correct, that things are behaving as you expect. And this is only going to, worst case, you'd probably be thinking about this for be involved in this for a couple hours. Bug fixes can be a little bit open-ended because you have to sort of triage it, figure out what's going on. Chisel standard library additions. So this is if you have something that you would like to add to the Chisel standard library, get into what this could mean, but this could be something like a state machine library, which is something which Chisel does not have. You might be thinking about this for something like weeks. Chisel APIs for FIRRTL features. There's a lot of stuff in FIRRTL that is not necessarily exposed up to Chisel. So something that was mentioned yesterday, like boring utils, this ability to do synthesizable cross-module connections. That's both a Chisel API, which is boring utils, and then there's a FIRRTL transform called the wiring transform. The wiring transform, the original version, Adam wrote a long time ago, but there was never a Chisel API for it. So that's part of what boring utils is just, hey, we have this cool thing in FIRRTL and we want to make it accessible to Chisel users, okay? New features, so this is sort of, pie in the sky, think about what's missing, what do you need? This could be something like, asynchronous reset, which is sort of the classic example, which we do have support for. But this is going to be a longer sort of involvement because there's a big push in the developer community to try and really think about the problem and come up with good solutions so we don't wind up in local minima. And then finally, infrastructural changes. These can go on for a long time. So this is stuff like if you were thinking about something like stage phase, this is 1 year, 2 year kind of a thing to get all of this pushed through. So really what the structure of this talk is that I'm going to sort of step through these things sort of one by one, showing some live code examples of sort of how to make modifications, how to, get PRs in, and sort of what I was planning to do was just see how far we get. Because generally what this would work for, most people, if you're not already contributing, trying to think about these sort of higher levels of contributions, the early stuff like documentation is a great gateway to becoming a Chisel and FIRRTL developer. So, all right. So first thing, so a note about environments. If you're going to do any of this, probably just use IntelliJ. This is great. You just download IntelliJ. It works on Mac, OS, or OS X, Windows, Linux, whatever. It's fine. You'll get nice stuff like you can go to definition. It'll give you, it'll underline errors for you in your code, and it'll just make your life a lot easier. Alternatively, use an editor that supports Scala metals and install metals. So basically what this is something where you start up your editor. In the background, there is an SPT session that's running, and it's basically providing IntelliJ-like features for you. But this is not for most stuff, this is not sort of just a one-step download it and it's good to go. With that caveat, throughout this, I'll be using Emacs and metals just because my fingers have certain memories and they can't be retrained. And then also just other helpful things that you'll probably see through this. If you're working with Git repositories, it's really easy to use this thing called git prompt, which just and use a customized bash prompt so that you know what branch you're on and whether it's been pushed to master, stuff like that. Just things that make your life easier. If you use IntelliJ and you only work in IntelliJ, you probably don't need this. But I'm just trying to say this is the environment that I'm using, and just so that it's documented to some extent. Let me just show that really quick. Scala metals. But if anyone was an Emacs user before, this is sort of the replacement for something called Enzyme. But this is sort of just something which is agnostic in terms of the editor, and for most editors, this just works. So in a sense, you can just download Visual Studio Code, and it should have all of these nice features of things which you care about, which is usually find implementations of stuff and go to definition. Because these are big code bases, and you'd like to be able to jump around. All right, so first thing, the website. So there is an old Chisel website, and there is a new Chisel website. Now note, this is technically a link to the archive.org version of it, just because it's not if you go to chisel.ex.berkeley.edu, it just redirects you to the new website. This is the old website that some of you may remember. It is on archive.org if for whatever reason you really want to, there was something on there that is missing in the new website. You can always go here for that reference. This is the new website. So sort of the way that this is structured is that the main page is just the Chisel 3 README. This is something that we've been thinking about trying to improve. Internal to this, the wiki was migrated over into this sort of wiki-like thing. And I'll get into basically how to make modifications to this going forward. You have one of these for each project. And so like if you go to FIRRTL, there's API documentation that's published for every tagged version that we have. So if for whatever reason you're on FIRRTL 1.1.1, you can open this up and get FIRRTL 1.1.1 documentation. Okay? So this is all there. Use this resource because this is something that's super useful. And then just to talk about the community stuff on this, which you've seen. So if you have projects, and I will probably file a pull request just to update things based on what people have presented here today for different projects that are then using Chisel and FIRRTL. But this is sort of the contributor section that I was talking about. When the website is built, it talks to GitHub and says who's contributed to these projects, and then if you contributed to these projects, you get your name up here. So there's a lot of people. All right. So anyway, so that's the website up there. But the question is then, how do you contribute to the website? Okay, so the website is maintained on a GitHub repository, which is FreeChips project. Eventually, this will be Chips Alliance at www.chiselang.org. So that's here. And what we'll just do is we will quickly grab a copy of this, make some edits, and then file a pull request on that. So I'm just going to jump in here. If this is too small, which it probably is. All right. So just following along here, git clone, git add github.com. Actually, and what I can do so this isn't quite as bad as I can just drop that in there. All right, so I'm grabbing the website, and the structure of the website is such that yeah, this is way too small. Just give me one sec here. All right, it's a little better. Okay, so the way that the website is structured is basically there are submodules for all of the Chisel projects. So Chisel 3, Chisel Test, Chisel Testers, Diagram, or FIRRTL. The only reason why these are used is just so that you can grab the READMEs and use them to populate parts of the website. They're not used for anything else. Now, however, with this, as I was mentioning on the website, there's API documentation for everything. which is not shown here. But if you show here on Chisel 3, go down to the bottom, API documentation for everything. So the only problem that you have if you want to actually do work on the website, there's a make file that'll build it, but you need all of the website all of the documentation that's ever been built. So if you want to let your computer sit there for, literally like an hour and a half while it builds all of that, that's great. However, what's better is I do have a release, which is a populated version of the API docs, which you can just download and then untar that in your build, in the directory where you checked out the website, and this will then make all that easier for you. So I can then, from here, just grab that and see how fast the internet is. Hopefully it's not too bad. Okay, not too bad. And the website uses something called SBT microsite, which uses two things behind the hood. One is called Jekyll and one is Jekyll redirect from. Jekyll is just sort of a static website generator, and Jekyll redirect from is a gem Ruby, which allows you to encode redirects. So this is where like there were old website links, which we had to map to new website links, and this is using this Jekyll redirect from to handle it. All right, so we have that. Yes.
Do you have this information somewhere on the README or something?
I think there is some of this on the README, but it probably needs to be updated a little bit more. Yeah, okay. So the big thing here is that when I untarred that down here on the right, and WebEx likes to hide stuff, so we'll do that. Okay. So what that did was that populated this build directory here, which has API docs, and in this case it has Chisel 3, everything there, okay? So basically all this is doing is this is saying that if you type make serve, which is going to try and build the website and then host it locally so we can take a look at it. And this will take a little bit of time, and I'll kind of just let this run in the background, but I should have updated submodules first. Okay. So that'll go.
What's the unit?
That's the Fedora installer. It's the.
What's the command on the Mac? Well,
so that's my only problem is I don't know if this will actually build on a Mac.
okay.
Yeah. There was.
Yeah. Try to okay.
Yeah. So that is one thing. Like I don't have a Mac. I don't have a Windows machine, so I don't exactly know how to build this on anything which is not Linux. And I believe Chick was trying to do this before, and there were some problems. So that's also one thing. That's an open issue. I'd like to be able to work on it, but I wrote this on my own machine. All right, so we'll let that run in the background. And that's basically just showing all of this stuff. Grab it, update all the submodules, make sure you have the dependencies available. I didn't populate the link just because it's long, but grab the build stuff, clean up the directory, untar it, and type make, wait a little bit. Unfortunately, the turnaround time is not currently great for building the website, but there are things you can do just for testing the type check stuff. Okay, so sample contribution, right? So you have this, what can you do to make the website better? So the first thing that you do is if you want to look for something that you can do, check the issues that are available. So in this case, jumping over here, back to my Chrome session. Right. So currently the website is using something called mdoc. So what mdoc does is it allows you to take something that's in like a Scala code shed. So normally we're in like Markdown, you type like backtick, 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 Scala, you put some Scala in there and then close it, backtick, backtick, backtick. mdoc lets you actually take that and compile it. So the benefit is there are certain things on the website which are actually being run against a specific version of Chisel, and they're guaranteed to be correct. So this is what this fundamentally means is if you go on the website and you look at the documentation for modules, which is one of the things which actually has this, So like, this is being, before the website is built, this is silently run through the Scala compiler. It runs through Chisel, it runs through FIRRTL, and it verifies that this thing actually is doing what it's supposed to. Well, in this case, it's just making sure that it would build. But basically what this is guaranteeing is that, I didn't forget a brace here, or I misspelled module or something stupid like that, where anything that's here, you should be able to copy and paste it into a terminal and it's supposed to work. That's sort of the fundamental guarantee that I want to be able to provide here. And that's what MDoc is then trying to do. Now, however, a lot of the stuff on the website was copied over from the wiki, and that did not have any of this MDoc stuff available. So there's been sort of this long-standing open issue of just taking existing things, migrating them to MDoc, and fixing them if they're broken, because some things are broken. So this is like a very sort of straightforward way that you can get involved with this. And what I'm going to show here is just fixing one of these things, right? So the structure of the website is that the stuff that you saw, let's go back. All of these things are under docs, source, main, tut, I think. So docs, source, main, tut. So you see stuff here like there's a Chisel 3 directory, community, contributors, index, etc. So inside of Chisel, if we go to that modules thing that I was then showing here, so that specific code example that I was showing initially, it's in this Scala shed, but it has this additional sort of, I forget what it's called, a flag or a tag or something like that, but it's saying mdoc silent. So what this will do is this is saying take this tut shed, Scala shed, and then run it through the compiler, make sure that this thing works, but don't show me the output, because I don't really care. I just want to make sure that whatever I wrote here is not going to, barf in the compiler immediately. Now, however, if you look at something like ports doesn't have any of this, right? So in this case, for this class decoupled extends bundle, this is on the website, but there's no guarantee that this works. This does work, but it might not. So what we then want to be able to do here is make a modification to this of saying Scala mdoc silent. And I realize this is like a very basic modification, but it is important. And the website is still not fully built yet. Let me just let that go. Yeah.
So you said you're copying stuff from the wiki over. So does that mean that if I update the wiki, then the website doesn't update?
No. So that was sort of like a problem that so Edward was trying to look at a solution for that, and I don't think here I came up with a good answer for it.
So does that mean we're deprecating the wiki?
It's a little bit of I would be in favor of that, if only just so that we could provide the ability to type check stuff and guarantee that it's right. But there is an ease of accessibility on the wiki that is not available for this, because as you can see, I'm downloading 130 megabyte tarballs and unzipping them, and it's 2 gigabytes of API documentation just so that you can type make and wait 2 minutes. So I understand there's a lot more overhead in terms of doing this, but I'm not 100% sure how to handle that. So if anyone has any solutions or anything better than this, I'm more than happy to be open to that. All right. So anyway, so if you're able to then take these things and actually edit them. So what you can do here is you can just pull up an SBT shell in this and type docs mdoc, and that'll just take all the documentation and compile it, run it through these things, run through the Scala compiler, and then if it errors, it'll error immediately. So just waiting for this SBT session to come up, and yep.
What is SBT?
Simple build tool. Scala build tool? Okay. The S stands for something. Okay, right. So SBT is basically a way of grabbing a bunch of dependencies for your project, taking them, and then compiling the project and running it, I think. But basically what that is it gives you like a nice interactive session where you can build your project. But in this case, if you take this and type docs, mdoc, with the modification that we wrote here, this will actually not compile. So the reason for that is that we don't have the correct import in place for this, which kind of makes sense. Like if you were to just take this, copy and paste on your terminal, it would not work because something called bundle is not defined. So I'm just waiting for this error to come out of here. And notice that you do see stuff like the FIRRTL compiler does run for some of this, which is some of these things you're actually generating Verilog and then looking at the output and dumping that back into the website. Okay, so we got errors. This is good. Really what this is saying is that bundle is not defined. Okay, the reason for that is just that you need import chisel3 _. Whether or not you want to include this on mdoc snippets is, you can hide this inside of something which is going to be executed but not shown, which is totally a fine way of doing this, but this is just another solution that you can use here. And then I believe the rest of this example will just work. Oh, wait. Great, totally killed it.
Is it also okay to contribute to the website without building it?
Yeah, so that's the other thing too, is you are totally free to contribute without going through any of this build process if you want. So all of the regressions will run, and all of this will happen on continuous integration.
Yeah.
I currently don't have a lock set up such that if it doesn't pass CI, we can still merge it if we really want to, which is mostly just for the situation of if you really make a trivial change, like we don't need to wait for the CI to run. But generally, then you will just be in the loop of waiting for Travis to churn through and build stuff for you. So anyway, I unfortunately killed my SBT session here, and this is now I have to wait for this to come back up. But basically just what I'm saying is there's a fair amount of useful work that needs to be done on just getting this thing up to date. For this case of ports, this did not involve much modification to the actual Scala code or the Chisel code here, but there are other things where there may be a fair amount of updates. Yes, Colin?
Just run like a reged version of all this, how many do?
So this kind of modification, there may be a lot. So there was stuff like with the annotations documentation, which was pretty out of date. I haven't tried that, and that would probably be an easy thing to just do and just see. But yeah, fixing this can be kind of tedious when things are out of date. Yeah. Okay. So this is back up. That'll run through. In the meantime, what I can do is grab one more session. And okay, so first thing having a working knowledge of Git is also going to be useful. So basically what we want to do here is Git checkout, new branch name is mdoc ports, Git status, Git add. Fine. All right, so what you see here now is the website built. Really what's going on here is that I can find it. This is getting compiled into basically you're taking this markdown, processing it, generating more markdown. In this case with mdoc silent, all that's happening is you read this and it's dumping out the original as long as it doesn't fail into a different markdown directory, and then Jekyll can then be used to build out and make the website. which if you type make serve, that will then go and run Jekyll, build the website, and do all of that. But that's a little bit slow, and I hope it's just WebEx for the reason for that. But anyway, so basically you're able to make a contribution like that. Commit this, so then migrate ports.md to mdoc, git push this onto the website, go to the website, this will show up, and it's sometimes useful to then just tag for what's going on here. So you can view your change, create a pull request, and then let that go and churn through regressions. So this is also a way you can kind of blindly make modifications. People would need to fork, yeah. If you're not in the free chips or Chips Alliance organization, then yeah, you would need to fork. Okay, so that is sort of the level 0, but still incredibly, incredibly important way of being a Chisel and FIRRTL developer. So, and the thing with like this mdoc nonsense is that it's super useful, but it's just a lot of work, and I just don't have that much time to then go there and keep the stuff updated. So the big thing that you can do is, even if you're not interested in doing this kind of stuff, if you look at something on the website, you try it doesn't work, file an issue, or better yet, just go through this little process of fixing it for us. And we've had a lot of like nice contributions from external people doing just that. All right, Schuyler. So yeah. So Schuyler, what is Schuyler? So this is the stuff of when you go to the website and you go to the API documentation, and well, actually, I'll let that load in the background. So Schuyler is intended to be sort of your initial point of reference for some Chisel or FIRRTL feature. It's like you heard about something called boring utils, but what is it? How do I use it? What is its API, right? The only place that is currently documented is in the Schuyler. And for all new features or anything new that winds up in Chisel and FIRRTL, we're sort of draconian that has to have good Schuyler doc associated with it, just to try and kind of fix the problem going forward before we try and fix the problem going backwards. So it's how you document your APIs. And then just what I'm going to show here is just a few things on the website then about this. So I did already show you that we have multiple versions of the API documentation. In this case, the latest is pointing at the 3.2.2, which is the most latest one. But you heard about boring utils, and you want to go and look at it. So you pull this up, and you get a lot of information, right? So what is boring utils? It's utilities for generating synthesizable cross-module connections that bore through the hierarchy. Cool. How do I use it? There's examples here that then show, start off with a basic example and then show different types of boring that you can do with it. All of the methods here have full documentation on it, and that's great. So at least the thing is, this is sort of intended to be that initial point of, what is this? How do I use it? And obviously there are more potentially useful things for this, like one of the things which then I also showed yesterday is mux lookup. So it's a little bit more Spartan, but it's still there, and it gives you, something. It creates a cascade of nmuxes to search for a key value. Okay, that is basically, that is what it's doing, but it's more descriptive than if there was nothing here. Okay? So, great. I don't hit restart. 22, is that 22 hours? Yeah. All right, that's fine.
Break it for 33 minutes.
You just close it?
Try it.
Wow.
Well, we could just slide it down to the bottom. Does that work?
Well, yeah.
Okay. Out of sight, out of mind, right?
Okay. What did I do? Where's the full screen?
Okay. Okay. So, you saw this with boring utils. Okay, great, but how did I write this, right? So if you go into the Chisel source, or this, in this case is the Chisel source code. Nope, not there. Inside experimental, there's a boring utils file. And what this is that there's sort of this inherited from like a JavaDoc kind of style for writing documentation. All of this is what you're seeing that winds up on the API documentation on the website, right? So anytime that you write something in for the Chisel or FIRRTL or these other projects, you're sort of expected to write this along with it. So note that for this, you do have these kind of code sheds similar to what you have with MDoc. Unfortunately, they're not type checked. So we just have to, at this point, I don't have a good solution for how to make sure that, I don't have a good solution for type checking this. Maybe somebody has something or something exists. But at this point, we just kind of have to just be careful and make sure that this stuff is right. But there's a lot of sort of not super well documented features in ScholaDoc for how you do formatting, how you do links, that kind of stuff. If you have questions, I can probably point you in the right direction. So, right. So how can you improve the ScholaDoc? All right, so the first thing is there are things which are still undocumented, and if you can write documentation for them, that's great. So this actually will make you a better Chisel developer because you have to actually look at stuff and figure out how it works, what does it do, play with it a little bit, and then you're going to understand it better. So there was a period where all of the Chisel and FIRRTL developers were pushing to document everything in the Chisel standard library. And there was stuff where I had to look in there and learn about stuff that I didn't know about, didn't know how it worked, and that was actually fun. So it's one good way to kind of force yourself to say, hey, you know, I want to become better and learn more about the features that are available. You can also then just improve existing documentation. There's stuff that's maybe a little Spartan, or you know, you could expand it out, or if it's something where you go and you look at the API documentation and you think, oh, like this is missing something. You know, either file an issue or better yet, hey, you know, clone the repository, file a pull request. You know, that would be great. So just showing quickly one of these situations about how things could be improved. So if you go for the when documentation, so let's say you're a Chisel user and you go and say, well, how does when work, okay? I go and I look at the when documentation, I'm greeted with this wonderful thing, okay? Now, this isn't really as bad as it is. It's just that the documentation for this is on the apply method. So you have to go down here and open this up and look at this. So really all of this is this could be improved if this example was moved up onto the actual object as opposed to on the apply method, okay? So if we can then go and then make that modification very quickly, and if I can remember exactly where, I'll probably have to search for this because I don't know where it is. I think it is in, all right, easy way. So the other thing too is on the API documentation, there are links to the version, the correct version of the Scala for this. So like if you click on when.scala, that will take you to the version 3.2.2 version of when.scala. So you can also use the API documentation to find out where the source files are, and then also go to that specific version if you're concerned there might be a bug with that. All right, so this is what I wanted to find. This is in Chisel front-end source main Scala. Okay, so really just what's going on here is that the documentation is probably a little bit on the wrong thing. So what we can do is just copy this down. So this could probably potentially be improved a little bit more, but just what I was trying to show is, this is like a sort of a simple modification that you can immediately make. Okay, now how do you test to see, what modification I made looks good? Because you don't want to just submit this PR and then wait for it to eventually get pulled into the website, the next version. Okay, so what you can do is you go into the Chisel 3 directory, and my directory is not clean. Okay, sorry about that. But basically, all you do is you type SBT, and it's either doc or unidoc. Chisel 3 and FIRRTL, it's unidoc. SBT doc will always work. SBT unidoc is sometimes enabled on the repositories. So what this will wind up doing is this will actually build the API documentation locally, and then you can load it up in your browser and take a look at it. So this is also something that's like super useful if like you're going on a plane and you want to have the documentation available for you while you work, but you're not going to have internet, or you don't want to pay, $20 for really slow, airplane Wi-Fi. And just give this a sec to get going here. So file, repos, github.com. All right. So this is the old version. This is not fully populated correctly, but this just shows up in the target Scala-version unidoc directory. And this is not built yet. It's still churning through, I believe. Okay, that's interesting. Anyway, all right, so we will do SBT doc. All right, this is taking a while to go through, but so I may not be able to specifically show this change. But this is a full copy of the documentation here. This hasn't shown up because this thing has not been built yet. And that will take a while. But anyway, there would be a feedback loop where you can go through here and then look, and then you'll see the when documentation show up here, and you can iterate on this, make sure that your code examples look right, all of that kind of stuff. So this is like a super easy way to then get involved, and then you can obviously then take this and file a pull request just like we did with the website. Okay? All right, let me just go ahead and kill this so that this is not churning through everything. Okay, so that's all. And I realize that I've talked a lot just about like how you can help with just documentation. And I realize that, maybe you're hoping like, oh, how do I like fix all the Chisel internals, okay? Start small and then kind of build up from there. So sort of the next level of thing that you could probably think about that's sort of a next kind of step here is just writing tests. So there are specific things inside of the Chisel standard library or some other places which just may not have tests. So in this case, there's something like chisel3.util.pipe, which is something which just creates a pipe of registers, I believe with a ready valid interface. I'd have to check, but this doesn't have any tests currently. So this is something where you can jump in and get involved with the actual development very quickly. And the intent was then to show some of that. So I believe this is source main Scala. All right. So in this case, you have pipe. It has nice Scala doc, but there's no associated test with it. So first off, sort of when you're going to write tests, the best thing to kind of think about are, some questions before you even sit down and start writing the test. So the first thing is like, what is a pipe supposed to do? And generally, it's best to think about this without looking at the actual source code that you're trying to test, just so that you're not biased by just basically writing a copy of the module that you wrote, or the copy of the module that exists, and just verifying that it, that Chisel works. You're not supposed to do that. So in this case, if we were to say, go here and pull up the pipe documentation and read it, and then think about, what is this actually supposed to do? So this is a factory for generating a hardware pipe. It can be used to delay valid data by design time configurable number of cycles. And here there's a couple of different pipes being shown here. I think this actually, so the first thing is like, what should the pipe do? Whatever you have as the input, that should show up at the output some number of cycles later. Okay, that makes sense. It's probably good to test that for a couple of different scenarios, like for a delay of 1 and a delay of 4. Also, the question is, what should the behavior be if the delay is 0? So for that, you would probably have to go and check the source code for this to see how that is actually defined. So in this case, let's see, pipe. So in this case, for a pipe, if the latency is 0, it's just the direct connection going through. Okay, that makes sense. So that's sort of one corner case that you should have to also test. Now also there's this requirement that the latency is greater than or equal to 0. Okay, that makes sense. A negative latency, violates principles of physics and all that. So what you would also want for your test is something where you are passing in a negative latency and then verifying that what error you're getting or what exception you're getting at elaboration time. Okay, so we've sort of come up with like roughly three tests that we need here. We need one to test the exception behavior, one that's going to test the the boundary condition of 1, and then something that's going to test the other conditions of like 2 and 4. Okay. So what does this actually look like? So inside of the Chisel 3 directory, there is source, test, Scala, Chisel test. So these are all of the different tests that exist for the Chisel 3 project with subdirectories inside of this. So all of this is, we don't just write code for Chisel and then publish it and, hope that everything's good. There's tests for everything, and this is what part of this process is then trying to do. So if this thing will ever get going. But generally what it is that you type SBT and then you type test, and that will run all the tests. That takes a while, but for what we're trying to do here is just to run one specific test. So SBT also has certain things like you can do test only, which will just run one specific test, which is frequently what you're doing if you are, say, adding an additional test for something like a pipe. Yeah. All right. So we'll try and then write this quickly. And I am doing some cargo cult programming just because I cannot always quite remember exactly what is needed here. But so all the testing uses, we don't need Scala check. All right, fine. So, but generally the test follows sort of I don't know exactly what the word is, but it's sort of like a linguistic grammatical way of describing what the tests are. So in this case, you would say something like pipe should throw an exception if latency is less than 0. Okay? And what's usually pretty good here is to try and write out all the tests before you even start. Write out what the tests are supposed to do before you even start writing the test. It's just good to sort of separate these things and think about what should a pipe do, and then think about the implementation of that. So just then, the additional things we talked about, pipe of latency 0 should be a wire. Okay. Property, pipe of latency 1 should delay signal by 1. Property, pipe of latency 8 should delay signal by 8. Okay, this last one is probably, is probably superfluous relative to the pipe of latency 1 should delay the signal by 1, but anyway, it's not exactly hurting anything to then do this. So, all right. So anyway, we're running a little bit short on time, and I'd probably like to switch over to take some questions. But generally, what this is that Scala test allows you to do things like check for exceptions, check the exception type, check the exception message that's then coming out of things. Additionally, there's also all of these. So if you notice, this is using like Chisel prop spec. So there's a whole set of internal non-published Chisel testing libraries which are trying to help and make your life easier for writing these types of tests. That's all in probably 1 or 2 files called chiselspec.scala and also util.scala. And generally the best way of sort of figuring out all this stuff is sort of looking at examples in the test directory, because it's, this stuff is used pretty much everywhere. One thing which we've talked about is then switching away from sort of the testing that we're doing now and moving over to using testers2 or Chisel test to do the actual testing. But that's something that hasn't exactly happened yet. But anyway, what I can just show quickly is, which we haven't had time to write the test for the pipe, but in case of the test that exists for the queue, you can just type test only and then the name of the test with the full package name, in this case, chiseltest.qspec, and then this will then go and run all of the queue tests. So if you were writing tests for your pipe spec, you would just say, test only chiseltest.pipespec, and then it'll go and then run through and run these tests for you. And then you can iterate on the test and make sure that everything works. So maybe then I'll, actually what may be slightly more useful is to just kind of jump through a few more of these things here. Yeah.
I'm next, and if you want to eat into my time,
I don't want to eat into your time at all. This is like way too much detail for I think most people. But maybe just I think what I'm just trying to do is I'm trying to get you hooked on Chisel development and just give you sort of like what is the easiest way to help start making contributions and become more connected with the community. So documentation is a great way to do it. Testing is a great way to do it. That'll get you engaged with the community, thinking more about it. And from that point, then that's sort of the jumping off point for more, more advanced things of thinking about bug fixes, thinking about Chisel standard library additions. In this case, state machine libraries, like I mentioned, checksums, migrating pieces of rocket ship that are super useful and getting those integrated with the Chisel library, error correcting codes. There's a whole issue related to this stuff. And then new Chisel API and features. And yeah, if you're going to do infrastructural changes, probably rethink your life priorities. Anyway, so that's it. I can probably take like one question or 1 or 2 questions, but thanks for listening and bearing with me through that.
You could also mention the IP contribution repository for
Yes.
a little bit less easier entry to contribute.
Is it IP contrib? Man, WebEx. Yeah, so the other thing is like if you have some project that is generally useful but is not something which may make sense to integrate with the Chisel standard library, like it's too big, like say it's like a SHA-256 or something like that, that's probably not a primitive you want, or a UART or something like that. We do have an IP contributions library, which is sort of this thing which has been mentioned before of you can pull in, you can define some code, we'll have it in here, and then it'll be tested along with new releases. So anyway, but I can transition over to Adam here and take any other questions that may come up in the interim.
Are we at MP1?
Yeah.
Yes, okay. Make sure I joined the right WebEx.
What are the tests used to run
So all of the Chisel tests at this point are using FIRRTL, as far as I know. A number of I believe FIRRTL is being used for pretty much everything. There's been some things can be sped up a lot if we switched over to FIRRTL. So that is like one of the things is that like if you want to run all of the Chisel tests, there's probably like 20 minutes. If you're on a machine that has a lot of cores, it's trivially parallelizable and will go a lot faster. But yeah, I mean that's another thing. You know, can we speed up the testing, make it better? And even at this, I'm talking about adding tests. It maybe makes sense to remove some tests. You know, if you look through it and you see, hey, this thing is really not testing anything useful, we can pull it out. Sure.
If I internally locally modify, say for example, like the example we showed yesterday,
Yep.
or the mark, and I may be making input as a function based on the Chisel version. I just got it working, and now another Chisel version comes up and I pull it and say something great.
Yep.
What is the best practice you would suggest to task this to root cause what broke and why?
Sure. So you're saying you make a local modification and then something else breaks?
No, I have a local branch with local modification. And then a new Chisel version comes up. Say, for example, we use it in the month.
Got it. Yeah.
And then I was making input as a function before without realizing it, right? Because a whole lot of things are there and
Yep.
it just happened to work.
Yeah. So generally in that situation, if that happens, the most likely thing that you would see is, okay, I think that what would be going on there, in most situations, you would not run into that situation. The only reason is because we are maintaining the same API across minor versions. So usually what something like that would happen is like if, hypothetically you work with Rocketship and then some API was removed, and then suddenly your code doesn't compile anymore, but you had local modifications, right? Now, the other thing is, if you have something where you have like a custom FIRRTL transform, you bump FIRRTL and then your transform no longer works or isn't behaving correctly anymore, that's a more difficult thing to debug. But the first thing to do for that would be to go and look at the release notes. So like to figure out, where was I before I bumped or, I rebased my changes on top of master, what's changed in that interim, and then try and, at least at a high level, think about, what could have affected it. If you really have problems with something like that, Git does have something called bisect, which will do a binary search of between 2 points in the Git history, and it'll keep running. You can tell it to just automatically run a test until it fails. So basically, if you have something where it's like, okay, this is like really nasty and really ugly, I don't know what's going on, you can try and set up a test that just it'll do a binary search to find like what specific commit was causing that problem. So there are tools for that, but that kind of stuff can be problematic. But if you do see that, you can file an issue and say, hey, I was doing this, something broke. What's going on?
And it's not really syntactically broke, but can be semantically broke also.
Yeah, so I'm not sure where, I think Adam's coming back, but yeah, so this is IntelliJ, which is going to look a lot more featureful than the stuff that I was showing, but just to give you different variants, this is the best way to start. Use IntelliJ, things just work, you just load up a project, you see the project on the left, you get keywords highlighted, you can do go to definition, you get an SVT session down here, so this is the SVT shell. And it's like a nice, easy, integrated environment for doing all of your work, and there's really no setup required. So I think this is what most people are using. I think you're using it. Use it, Martin? Okay.
I use it, it is one. It's really a testament for Rocketship. It's a bit of a pain, but once you guys understand your code base and you tell it like what the source trees are, then you know how to run close to more.
We're good?
We're good.
Okay, sorry. Coffee hit me. Okay. So, how's everyone doing? Feels a little quiet. Yeah, you guys want to take like 5-10 minutes? Yeah, people smiling when I said that, so let's do it. Come back here at 10:15.